Hello dear learners, this is Prabha Biju, Assistant Professor from the Department of Computer Applications in the Bhopal School of Social Sciences. In the previous module, I explained you about process management, where we learned that a part of a program, when moved from the secondary memory to the primary memory, then it is known as process. A piece of a program, when moved from the secondary memory to the primary memory, is then termed as process. This module, we will be learning process scheduling. In this module, we will be covering following topics: process scheduling concepts, process scheduling queues, two-state process model, scheduling objectives, and types of schedulings that are long-term scheduler, medium-term scheduler, and short-term scheduler. Now let us understand what is process scheduling concepts. The process scheduling is the activity of process manager that handles the removal of running process from the CPU and selection of another process on the basis of some particular strategy. It is an essential part of a multi-programming operating system. Such operating system allows more than one process to be placed in RAM. Let's say this is primary memory, and in the primary memory, in multi-programming environment, n number of programs can be kept, like process 1, process 2, process 3, and n number of processes. In process scheduling, operating system allocates a time interval of CPU execution for each process. And another important reason why we use process scheduling is that it keeps the CPU busy all the time, which is one of the objectives of operating system, and it also reduces the response time of a process. Now let us understand what are process scheduling queues. Process scheduling queues helps to maintain a distinct queue to each and every process state and PCBs. All the processes of the same execution state are placed in the same queue. So whenever the state of a process is modified, it is unlinked from the existing queue, and again it is linked with the new state queue. So operating system maintains three main queues, that are job queue, ready queue, and device queue. Job queue keeps all the processes in the system. It has all the processes which is not yet created. And in the ready queue, it keeps a set of all the processes that are residing in the main memory, which are ready and waiting for the execution. So all the newly created processes are kept in the ready queue. And the third queue is device queue. The processes which are blocked due to unavailability of I/O devices constitute this queue. Now let us understand queues with the help of this diagram. The very first key which we have learned just now about job queue, which is also known as batch queue. So batch queue or job queue is a data structure that keeps all the processes which are not yet created. Next is ready queue. Now ready queue, as we have learned, that it has a set of processes that operating system has allocated all the resources other than the CPU. That means it is waiting for the execution, waiting just for the allocation of the CPU for execution. Now it is actually doubly linked list. It has two pointers, that is head and tail. So when we say that ready queue has the list of processes, actually it has the corresponding PCBs of those processes. So it can have n number of processes like PCB 1, PCB 2, PCB 3 and n number of processes. So, it has two pointers, header and tail. Now, the first pointer points to the first PCB in the ready queue and the second pointer points to the last PCB in the ready queue, and each process has the pointer to point the next PCB. So that was about ready queue. Coming to the third queue, that is called I/O waiting queue, or it is also known as device queue. Like when a process is getting executed and it encounters that it requires some I/O operation, such process is taken away from the CPU and brought into the I/O waiting queue, and these processes are then put back into the secondary memory. So that was about the process scheduling queues. Now let us check what a two-state process model. There are two states, that is running and not running. So in the operating system, whenever a new process is built or created, it is entered into the system and which should be in running mode. So when we talk about uniprocessor, that means it has one CPU. So at a time, one process will be allocated CPU for the execution. Second state is not running state. So apart from the process which is executing, which is in the CPU, all the other processes which are waiting in different queues are said as not running state. Okay, so the processes that are not running are kept in a queue which is waiting for their turn to execute. Each entry in the queue is a point to a specific process. Now let us see what is the scheduling objectives. These are the three main objectives. The very first one is to maximize the number of interactive users within acceptable response time. The second objective is to achieve a balance between response and utilization. That means it should have minimum response time and maximum utilization of CPU. And the third objective is to avoid indefinite postponement and enforce priorities. Operating system always gives the priority based allocation. And the third objective is to avoid indefinite postponement and enforce priorities. Operating system always allocate CPU on the basis of priority. Now the next topic is scheduler and its type. We have learned that operating system is an integrated set of programs. So scheduler is a program, operating system program or a module that selects the next job or process that should be admitted for execution, and that is the job of scheduler. There are three types of scheduler, that is long-term scheduler, short-term scheduler and medium-term scheduler. These schedulers can be termed as LTS, STS or MTS. Let us understand what is long-term scheduler. Long-term scheduler is also known as job scheduler, and the task of this scheduler is to select the processes from the secondary memory to the primary memory. And the primary objective of this schedule is to provide a balanced mix of jobs, that is processor and I/O jobs, that allows managing multi-programming. This scheduler regulates the program and selects processes from the queue and loads them into the memory for execution. Next is medium-term scheduler, which is abbreviated as MTS, and it is also known as swapping scheduler. It has the processes which requires to be removed or suspended from the main memory to the hard disk. They are handled by this scheduler. That means, as I told you earlier, that a processes, when they encounter that it requires some I/O operations, those processes are taken away from the CPU and put it into the device queue. That is done by the medium-term scheduler. Medium-term scheduling is an important part of swapping because it swaps out the processes from the primary memory to the secondary memory, and it enables to handle the swapped out processes. Next is short-term scheduler. Short-term scheduler is also known as CPU scheduler. The job of CPU scheduler is to allocate processes belonging to the ready queue to the CPU for execution. And its main objective is to maximize the CPU utilization, which is the objective of operating system also. Assigning of CPU to the competing processes has three major steps. Step 1 is context switching, that implies the switching of the CPU from one process to another. And the second step is switching from monitor mode to user mode. And the step 3 is restart the execution of process. Under this step, the process from where it has stopped earlier, it will be started again for the execution. So the time taken by the dispatcher to stop one process and to start another process is known as dispatch latency. So dispatch latency plays a major role in multi-programming operating system. The degree of multi-programming depends upon the dispatch latency. The degree of multi-programming increases when the dispatch latency decreases. So these are the three steps that is involved in assigning the CPU to ready process. Now let us once again understand with the help of this diagram long-term scheduler, short-term scheduler and medium-term scheduler. We learnt about queues. So queues are actually handled by these schedulers. The processes which are kept in the job queue are handled by the long-term scheduler. So when the processes are created, long-term scheduler moves it from the secondary memory to the primary memory that is in the ready queue. Then short-term scheduler assigns the CPU to the competing processes which are placed in the ready queue. And in medium-term scheduler does the swapping, as we learned that it is an important part of swapping is MTS swap out the processes which are waiting for some devices into the secondary memory. So these are the types of process scheduler. So I hope, dear learners, you have understand what are process scheduling queues, scheduler and its types. Let us once again summarize the topics which we have covered in this module. Process scheduling, which is an operating system task that schedules the processes of different states like ready, waiting and running. Then we have learned about process scheduling queues, that were job queue, ready queue and device queue. We have also understand the two-state process models that are running and not running. We have also learned in the scheduling objectives that it maximizes the number of interactive users within acceptable response times. We have also seen that a scheduler is a type of system software that allows to handle process scheduling. And finally, we have learned about types of scheduler, that is long-term scheduler, short-term scheduler and medium-term scheduler. Thank you.